Welcome to today's webinar about design patterns for agentic AI. I'm Eric Koslow, a senior editor in InfoQ focused on Java and security. And I've been in the Java space for a really long time, and I pay a lot of attention to what Akka does. They've done a lot of great works on distributed systems with their actor model, self-healing systems, and a lot of other things where they've gone through to figure out the hard details. Akka has another webinar about the blueprint for agentic AI services, which is a really nice introduction. That's available on InfoQ. Just search for the Akka microsite. This has design patterns, things to learn, and today we're going to go into some medium and advanced topics designed to help practitioners understand how, when, and why to use agentic AI. To answer some initial webinar questions, a recording will be available. We'll monitor questions during the presentation, some of which we will address during the presentation, others will wait until the very end. So write any questions that you have in the questions tab, and the more questions we get, the better it is. And with that, Richard and Tyler, we're looking forward to hearing more.
Thanks, Eric. Thank you everyone for joining. So we're here to talk about design patterns for agentic AI. And for today, we'll start by talking about large language models, agents, and agentic systems. And one of the themes you'll be seeing as we talk through this presentation is that agentic systems are really distributed systems, and building reliable agentic systems really means it's a system engineering challenge with some additional tweaks and nuances because large language models are stateless and stochastic. So we'll talk about those specific challenges in engineering agentic systems, and then we'll talk about system engineering practices that help you build reliable agentic systems. And then we have additional resources, and as Eric mentioned, we'll do Q&A at the end. So we're going to kick this off with a poll, just so we can make sure we're leveling the content appropriately. And we just want to understand where you are in your agentic AI journey.
Richard, we are focused on organizations that work with IT and R&D groups. And I think what we're going to see here is that there is a lot of research and experimentation. And more importantly, when we talk to IT groups, they are even earlier in their understanding and adoption cycle, mostly because there's going to be this transition from data science, data engineering teams into enterprises that have to do operational and industrialized implementations of it all. And if you look at that, that's kind of data kind of supports that we're in the earliest stages of that transition.
I think that's right, Tyler. All right, well then I will turn it over to you to talk a little bit more.
All right, so we're going to go into some slightly more advanced concepts around agentic AI today. We're going to open it up by just giving a brief overview of what agentic AI, particularly integrated with cloud native applications, the implications of that. We have a bunch of resources available on akka.io. You'll also have access to this document where those hyperlinks will allow you to click and go directly to those resources. But you can also just snapshot this, do a search for that, and you can see a variety of background materials to take a look at. All right, so what are we talking about here? And effectively, agents and agentic systems are distributed systems powered by AI. And we see this as a reasoning architect and a systems engineering discipline, because what you have to do is find a way to deliver a reliable outcome or a reliable set of behaviors while depending upon LLMs that have very long latency, high variance, and a certain degree of unreliability. And that unreliability generates basically randomness. And so how do you design systems to create very consistent, certain outcomes when you have randomized outputs associated with them? Now, AI agency is this capacity to make reasoning or make meaning from your environment. And just for us to have some common nomenclature here, what we've seen is the evolution over the last 15 years from low agency towards high agency systems, where high agency systems are things that can work towards goals and that they're highly autonomous. And the distinction is that we've had RPA, robotic process automation, for a good 15 years. And I think that the key distinction of that was that the decision criteria was coded. It was deterministic, if you will, and it was a structured rule set. And with agents, particularly single agent systems, what they do is they're using LLMs to get advice, and they probably interact with humans for humans input and guidance on that in what we would call an enrichment loop. But that enrichment loop itself is a very narrow and partial form of autonomy. And then what we're seeing now is you're moving all the way forward into agentic systems, and agentic systems are generally multiple agents working towards a common goal in a coordinated fashion. And there is a series of not just decisions, but information that's generated in a distributed fashion. And if you architect the reasoning model in just the right way, you get a higher form of autonomy. And what we've seen with this is that as we've been moving from the left to the right, there is a much higher overall productivity impact that you can get to your users or the systems themselves, but generally it also costs more to design those systems and then to execute them as well. So there's a productivity cost trade-off that we've been looking at. Now, what happens when you start incorporating your AI LLMs alongside your cloud native applications, and you start integrating these things together, what ends up happening is that you start building these powerful application ecosystems that can deliver one of three types of, let's call it superpowers or enhanced capabilities. That's generally personalization of interactions, particularly if you've got all kinds of different content streams related to a single user. You can use AI to not only synthesize that information, but then to make recommendations back to that end user. A big part of this is that we're going to see that you can use LLMs to actually take actions and make decisions. And so the combination of those things allow you to automate routine or mundane tasks so that humans can spend time on strategic efforts. And then the last thing you can do by integrating AI with your app is that you can teach the AI to sense the environment and then make recommendations or even adapt to the changing environment that's around them without necessarily increasing in cost. And so this gets into using LLMs on the edge or with IoT devices, or having the LLM learn from the interactions that it's having with humans to make smarter decisions on an ongoing basis. Now, one of the things that was very compelling and telling for me was that, as we've gotten better with understanding machine learning models and LLMs, what you're able to do is, if you can refine the input that you give into an LLM in a structured enough way, that you can get a structured output from that LLM. And when we talk about a structured enough way, that is a combination of how the prompt is written, the structure of the prompt, the context and semantic meaning that you attach to that, and also the selection of the model that you use. And if you do those things, you can get very structured outputs. And so as a result of this, you can now look at these as building blocks for how you start designing systems that can do higher forms of automation or forms of reasoning. And really powerful here is that, we've all seen sort of, you can give it a language input, ask it a question, and it will answer that question for you. But you can actually structure your prompts in ways where you can give it an API, a series of input parameters, and then a generic amount of information, and the LLM will be able to respond back saying, you know what, I'm processing your request. I need you to call this API with exactly these parameters. And so in using that, you can start doing routing decisions, having the LLM make decisions on path A or path B. And you can take this all the way down to having the LLM come up with a custom algorithm that algorithm needs to be executed. So there's a lot of very advanced sort of things you can do. And then the combination of these things, start to create an agentic system. And so once you realize that you've got these components available to you, now what you're doing is that when you evaluate your cloud native application, you're rethinking how you want that system to make its decisions. And so, and really AI or LLM based decision making is applicable in areas where deterministic or rule based approaches fall short. So if you've got a rule-based system and the rules are constantly changing on you, or that the rule set is very large, or that it's really difficult to reason about the rules, then that's a situation where you can actually introduce LLMs as a displacement or a replacement of that rule-based system. And you can teach it how to make those decisions on your behalf, because it's very good at synthesizing a wide range of inputs and then making recommendations on that. And so if you have that sort of environment, or the decision making is tied to a lot of unstructured data, LLMs are particularly good at working within that environment.
So LLMs are the magic behind this, in the sense that they can do that reasoning, that planning, and analysis. But an LLM is just a brain, so it doesn't have any memory and it can't perform any actions. And so in order to do that, in order for an LLM to be effective, you put the LLM in an agent, and the agent is actually responsible for getting all the context that's necessary for the LLM to make a good decision. So it retrieves that context, it sends it to the LLM gives a response back, and again, the LLM can't invoke an API, can't invoke a particular function. And so again, it's the responsibility of the agent, based on what the LLM says, to actually invoke that function or call that API, and then send the results back into the large language model. And finally, agentic systems is the term that we use when you have multiple agents. And when you have multiple agents that are collaborating and interacting, that's actually how you actually can solve complex tasks. So when you have all these agents working together, intelligence emerges, and this collaboration lets you tackle these higher level goals reliably. And I'll give a couple examples of how this orchestration actually functions. So one of the common patterns is prompt chaining. So you may have, imagine you have an agentic system that's about taking some ideas for some marketing content and publishing on a blog in 5 different languages. So in order to do that, you might have an agent that is focused on taking your marketing concept or idea, whatever topic it is, and creating that content, maybe iterating on that with a human. And then once that content is actually okay and approved, it will send it to a dedicated translation agent, which is a different agent. So that's sort of an example of how you're actually decomposing a task into sort of a set of sequential tasks. Another pattern I just want to highlight is the synthesizer pattern, where you actually have an LLM that's actually orchestrating the actual planning. So a good example of this would be if you actually have a research task, because in a research task, you don't know in advance the actual agents that you will want to do that research. So based on the query, your orchestrator agent may decompose that query into multiple components and say, well, I'm going to delegate this to the internet search agent, I'm going to delegate this to the Salesforce search agent, and delegate this to the Slack search agent, or whatever it thinks is actually appropriate. So these different patterns are actually what enable agentic systems to actually tackle higher level problems. And if you realize these workflows these agents have to be orchestrated, and agents are running on computer systems, and computer systems are just as reliable or unreliable as any other computer system. And so in this translation content agent, when your content agent is creating that content, if the server it's running on crashes, you need to be able to resume execution from the point in which it's crashing. So you need a durable execution workflow that also is traceable and auditable and debuggable, all these different things, because you actually have a complex distributed system that you're orchestrating where all these agents are really interacting together, and you need to make sure that it always finishes, and you can also debug situations where you're having a problem. So I want to talk about this enrichment loop that Tyler alluded to earlier. So in a single agent, this is the heart of every single agent architecture, if you will. In an agent, we've talked about how you actually get a prompt, right, which is the input to a large language model. You send the results of that prompt to the LLM actually responds. You save that response in memory because the LLM is not going to remember on a subsequent call what it previously said. So you save that response in memory, and the LLM typically will then respond with an API to call or a tool or an action or a summary. And so then it's the responsibility of the agent to call that tool. It gets the results from that API call. It adds the results to that prompt, and then it can call the LLM again. And you can run this multiple times if you're calling multiple tools, you're iterating, and that's actually how you get higher level reasoning. So to call this into context, a specific example. Imagine you're building a travel planning agent, and the goal is an itinerary. So you might send to it a prompt that says, I want to book my travel to some place to go skiing. It's May 1st. And so the LLM, instead of just immediately responding with 5 different ski areas, may actually give you an invocation, give the agent an invocation to check the ski conditions at these 5 different areas. And maybe 3 of them are closed because it's May and we're in the Northern Hemisphere. At which point it responds back, it gives the ski conditions of these 5 areas, and then the LLM runs through another iteration of this loop and then can give you a recommendation. So that's an example of how this enrichment loop can actually create more powerful and nuanced reasoning by just running this loop multiple times.
Yeah, I just want to add in there, Richard, that what's really important is that there's all kinds of different tools and frameworks that help facilitate creating an agent. But what's happening here is that you're really giving that LLM a really elaborate prompt, and inside that prompt are instructions of available tools that it can make use of. And when the LLM figures out that it needs to make use of that tools, it comes back and tells the agent, I need some information from this tool. Here's the parameters to use it. And so the agent not only does that work, but then updates the prompt as well. So it gives a synthesized version of the prompt back to the LLM so that it can continue on where it was. And so the prompt keeps collapsing down until it's a final outcome with that. And so the agentic framework has to automate all that sort of interaction with memory, interaction with tools, and the reconstruction of the prompt as it goes through that looping process.
That's exactly right. And this is where, when we talk about how LLMs are stateless, that context that you're sending to the LLM in the form of the prompt is assembled from all these different sources, right? So you're getting knowledge and facts from a vector database or any other sort of data source. You're taking the current conversational history as well as past interactions, if they're germane, from a memory database. You might be calling APIs and getting ski conditions or weather conditions from an API, which is more real time. And you might have event streams, like a video event, like maybe you're reading a webcam that it's at the top of the ski mountain, right? So all these things are actually being assembled by the agent to be sent to the large language model.
Now, we talked about how, reasoning is the coordination, the orchestrated coordination of multiple agents working with each other. We talked about agents as a enrichment loop, and we've talked about how LLMs are unreliable and stateless. And so if you want to build an agentic system that has both scale and is resilient, you are dealing with a distributed system problem. And this is obviously an area that Akka takes near and dear to our heart, and we provide a bunch of technology related to this. But there are specific distributed systems technologies that matter for each of these things. And when dealing with LLMs, the most powerful part of this is that they are stateless. They tend to be blocking activities. Their responses are chunked. And so you want to be able to use a connectivity layer that transitions that into an asynchronous non-blocking invocation, that the responses are no longer chunked, but that they're event-based and streaming. And oftentimes you're going to have be doing augmentation of real-time data, even though the LLM itself is incredibly slow. So you've got to be able to do real-time ingestion, augmentation of, say, audio, video data, and then back pressure so that you don't overwhelm the LLM as you send the request over to it. And when you're dealing with agents, now you have to recognize that many agent enrichment loops have human-in-the-loop interactions. That's usually some sort of workflow construct associated with that. You're going to want that to be an event-driven architecture, which means there's going to need to be retries, circuit breakers, and timeout. You will want to think long and hard about how you're going to do the tool integration and whether your memory database is going to be embedded within the agent or external to it. And then now, because you are dealing with distributed APIs and embedded memory, now you have to worry about replication and failover so that you can deal with agents that fail or even regions that fail on you. And with agentic systems, now you're talking about multiple services communicating over a protocol. That's durable execution with workflows, distributed tracing and auditing. They have to be able to do discovery and mesh networking so that they can communicate perhaps over disconnected networks. And there are a number of emerging multi-agent protocols that allow for discovery and back and forth communication between agents that are collaborating, particularly Google's A2A, and B.AI was recently submitted to the Linux Foundation coming from IBM.
So we have a poll question now as we transition to the next section. Which approach best describes how your organization is building agents? And I know that lots of folks are still sort of in the exploratory phase, but we're curious to get your perspective on this.
All right. Are people building single agents? Are they building agents integrated into their apps or off-the-shelf agents?
And I realize we probably should have made this multiple choice because they're actually not mutually exclusive.
That's right, yeah.
But maybe pick the one that is top of mind for you.
Look at that. So about half people are just still contemplating and learning. Yep. Standalone agents, but 35% building agents into an existing app. And that's actually a really high statistic. That's probably the area where we at Akka focus on the most. We have now about 50 agentic customers, and about a dozen of them are using AI in interesting ways. It might actually be more now at this point. But a lot of organizations that are integrating LLMs into their existing app, they are doing it either where the LLM can make recommendations that are then validated by a human, so it's got a human in the loop sequence associated with it, or they're using LLM to automate portions that really don't touch any sort of critical system, critical data. One example is we have a customer who has a bus system that generates about 5 to 6 billion events a year. And of those 500 to 600 billion events, there are 500 error messages that happen that are not able to be recovered through a standard retry mechanism. And these messages are important enough that it requires human remediation to diagnose and resolve. And they're using AI integrated with that error database to look at the 5 billion successful messages and then make recommendations on what is the likely remediation path to fix the error message that was in that standalone database. And so in that situation, the only impact is that a human's going to have to do the work instead of a machine. So it was kind of a good starting point for where they're at.
All right, I'm going to come in here and interrupt you a little bit because we have a questions tab over on the side where everyone's able to ask some questions, and we'll interrupt. We'll bring the important ones to you during the presentation. Others will hold until the end. But there was a good question that came in that is, I think, relates to the poll, which is how do we evaluate the agent and agentic systems? So you have people who are building it into existing apps, building it new. How do they evaluate them?
Go ahead. Yeah.
So if the question is how do we evaluate agent quality, we actually have a couple slides specifically around how to answer that agentic quality, because not to sort of preview too much, but in our view, your agentic system is only as reliable as your evaluation system, and
yes.
so it's a big part. It's a great question. So we'll touch on it and happy to answer some additional clarifying questions. But it's definitely a big part of what I would characterize as good system engineering practices for agentic systems.
Yeah, we're gonna hit upon that and explain exactly how you go about doing that. Okay, so let's talk a little bit. That was the kind of the appetizer. Let's talk a little bit about what are the challenges, and we're going to talk about these in the context of a system engineering approach. But what are really the things you got to think about in order to get something into production, to stop experimenting and really thinking about how is this system going to be something that I operationalize and run on a 24/7 basis. The first thing is that this is a survey that was recently done. It comes from Gartner, and 52% of projects don't make it into production. And furthermore, the time for these projects is more than 8 months to move from a POC into production. So even though you can build these agents and write these prompts fairly quickly, there's a lot of work that's going on between that initial idea and all the way to the final stage. So what's really going on here? And one of the biggest issues, and there's really 3 issues with what people cited as why they don't get there, is one, the uncertainty of it all. How do you trust these systems? The second is a security related issue. And the third is scaling these systems. And scaling is directly related to the cost of running them. And when it comes to uncertainty, what you have to recognize is that LLMs, no matter how much you constrain them, are a stochastic algorithm. And because it's a stochastic algorithm, that means it is randomized. And because it's randomized, then there is a variance associated with it. And so you can manage that variance, you can constrain that variance, you can restrict that variance, but that variance will always be present. And so the first kind of principle in how you're thinking about these systems is that you must just open up the idea that you have to embrace this uncertainty. You have to accept that these systems are going to fail. And then you also have to embrace the randomness and design a system that anticipates failure and expects randomness as opposed to trying to avoid it or eliminate it at the end of the day. Now, there's all sorts of little interesting points here, but a couple of things I'll just point out is that when you go into a multi-agent system, you are now compounding the randomness, and if you're going to design a system where there is a whole sequence of agents that are working in a pipeline, it's going to become an exponential level of variance that you have to deal with. That's one big thing. And then the second thing, and you're going to hear this, we're going to say this over and over again, the best systems are those systems that embrace an evaluation-driven development approach, meaning that you need to incorporate evaluation from the beginning, you need to do it during your development, and you need to have it in production as well. And that's because when you're giving an LLM or an input into an LLM, you're going to get a variance of responses on that. It is not possible to write an assert.equals. So evaluation is the technique on which you're going to use to quantify, observe, and verify whether the system is maintaining its accuracy within acceptable levels. So this is really about a mindset that we're encouraging you to embrace, and you want to bake this mindset into the very beginning of your project. Furthermore, if the portion of the system that you're dealing with has human input or is accessing critical data from your database or an event stream, there are a whole wide spectrum of security concerns that you now need to embrace. And the most common way that we've been able to come up with a metaphor for this is thinking of it as a leak or a leaky sieve. And the reason being is that the LLMs are not thinking, they are just pattern matching algorithms there. And so you can actually write prompts, or a user can give information back to an LLM that could accidentally expose information that you had no intention of exposing, because that LLM is pulling from a rich history of associations that could cause it to ultimately leak or feel like it's a sieve. And so there is a whole new class of security vulnerabilities that you have to anticipate and deal with. And now we're starting to see that there are controls that you can put in place in best practices, including that you can actually give the LLMs an identity. The agents can take on an identity and a role. They can have permissions. There's things you can do around memory hardening with trust controls and minimum access policies. And so this is an emerging field, but this work of kind of min constraint of the data is going to be how you deal with your data sovereignty and compliance issues. And then lastly, and we find this just so fascinating in that we actually think of Agentic as the fifth wave of compute. And the reason being is that we're going to see a double order of magnitude change in the transactions per second, on top of the fact that these LLMs are significantly slower. They are effectively long-running, blocking, not asynchronous processes that have really poor latency associated with it. And so if you have these agentic systems that start operating on their own, there's going to be maybe 20 agents for every user on the planet. They're going to interact with the backend systems way more frequently than a human would, and they're also going to be slower, and they're very expensive to operate. This is a no BS statistic. We took our largest customer who runs, zillions of transactions a year. They have optimized their system, and when we took a look at what does it cost for a database transaction on a single database transaction, and then compared that to the world's best performing open source model that's available, and it was 850,000 times more expensive for a single transaction with the best open source model than it was with a single database. So you can't use these things indefinitely. You're going to need to be very sensitive to whether you're going to use a hosted API with a model that is going to obviously have a margin associated with that, or you're going to try to own your own model hosting system. But cost, performance, and control of how this is all going to interact is going to be a factor you have to design into your system from the very beginning. Otherwise, you're going to blow your budget.
Okay, last polling question. We want to understand about what deployment model will your organization use the most for your agentic system? And it's, again, you're not sure, public cloud, virtual private cloud, or self-hosted, so in your own data center.
And really the question here is, are you going to own your AI, or are you going to partner and delegate it out to vendors with their hosted experiences?
Yeah, and Tyler, I think going back to the question about evaluation earlier, one of the things that I'm seeing increasingly is that organizations they do want the control and cost efficiency you can get from bring your own model, especially since the open source models are getting so much better so quickly.
Yep.
However, there's still a lot of value in the open AIs and Anthropics, but they're starting to lean on them more for evaluation purposes. So using open AI to generate synthetic data. And you can see this even with Microsoft this week announced a small language model called Phi-4. And where do they get the data to train Phi-4? Well, they got it from DeepSeek as well as OpenAI. So what I'm seeing is that these sort of state-of-the-art, these gargantuan models hosted by with like a gazillion PhDs working on them, they're actually using them to create the synthetic training data or the evaluation data that you then use to train your own model that is much more cost effective, and then you just self-host that.
Oh, about half and half.
Yeah.
Half going public, half self-hosted. I think that was almost identical to what we saw in the last webinar we did.
Yep. I think that's right.
That sounds about right. Yep.
Okay. Well, so I want to talk about, so Tyler just walked through the challenges of building agentic systems, and now I want to talk about the practices of how you address those challenges. So in terms of engineering agentic systems for reliability, I'd suggest sort of this sort of process. The first is just execute your standard domain-driven design process and add on an AI-driven design process, which makes you aware of all the different nuances of deploying large language models, which are hideously expensive, slow, and stochastic. And I'll talk a little bit more about them in a minute. Second step is to define your data sovereignty and scope. We've talked about how LLMs are only as good as the data you supply it. And so that context typically contains data that's pretty sensitive and subject to compliance regulations or company policies. And so you really need to understand that because that will affect your architecture. The third, going to the other question, is to establish your evaluation strategy. And I'll talk a little bit more about how you should think about your evaluation strategy, but it's really important to think up front, how are you going to evaluate if your agent is actually performing well? Because if you can't evaluate it, then you have no idea if it's ready for production. So once you have these three things sort of set and figured out, or at least a draft of them, you can then start having a discussion around what are the right AI models. And there's a lot of different choices, right? There are a lot of different types of models, ranging from reasoning models to small language models, which are more effective, to domain models that are fine-tuned for specific purposes. Most likely, you may end up using more than one model. Once you have sort of a general sense of the right AI models, it's about selecting the agentic platform architecture. You don't want each agent to be doing things its own way. That, for example, makes for impossible for you to actually code and manage that. And more importantly, you can't orchestrate agents if you don't have a common orchestration framework. So you really need to think about all the different requirements to manage this distributed system of agents. And then after all this is when you can actually start building a developer workflow, starting building your agents, and then you go through the deployment process and you think about observability, and that's a loop that will run sort of indefinitely as you add more features, deploy them, find bugs, deploy them, and so forth. So the core thing with AI-driven design is really about how you have techniques to reduce uncertainty. And there are three, I would say, main techniques that I'd highlight. The first is to create layers of certainty. So instead of delegating everything to a large language model, which would be very slow and very expensive with a high degree of variance, you want to think about how you create layers of certainty where you're very confident that this will actually produce a desired outcome, or it will help you ground the LLM back into reality. Because if you periodically ground the LLM, your overall variance is actually reduced. That's the first thing. The second thing is to incorporate eval-driven development, very similar to test-driven development. You want to continuously test and evaluate in development and production how your agentic system is performing across a very wide range of inputs. And finally, you want to choose an agentic AI platform that you know can operate your services scalably and safely, right? And so that means things like distributed orchestration, event-driven architecture, streaming, integrated memory, because all of these things are actually requirements for you to build an agentic system. So when I talk about creating layers of certainty, there are 5 sort of general techniques, probably more, but I think there are 5 common techniques. The first one, Tyler mentioned earlier, human in the loop, right? So you can actually delegate decisions to human in the workflow. So the LLM may come up with a set of recommendations, and then you can ask a human to approve or reject that recommendation, or ask the human for feedback. So that's a common way to actually ground things. The second, which is actually getting extremely popular, is agentic awareness. You can actually tell an LLM to spend more time thinking, or when it's not sure, to give you 3 different options and then to score those 3 options. And there's a lot of research right now that shows that by allocating more test time compute or thinking time, when you're asking an LLM question, you can dramatically improve performance. A third technique to create layers of certainty is to actually get a second opinion from another agent, right? So maybe you get the output from agent 1, and you might have a trust and safety agent or a style agent that's enforcing the style guide of your company to check that. And that's actually a very common approach, where you have these sort of checks and balances in a second agent, right? Or using OpenAI to check the output, even if the output itself was generated by Llama 4. Fourth technique is specialization. So you can limit LLMs to making decisions in their area of expertise. So I've been using this implicitly. You know, there's the trust and safety LLM, there's the translation LLM, but the more you can narrow the scope of responsibility of the LLM, the lower the variance. And finally, you can limit LLMs to a finite set of outcomes, right? So you can say, give me the output in a structured schema for machine processing, give me a choice between 5 different options, and you can actually say, you know, and this is very common. You can say, instead of saying, what do you think about this? What do you think on a score of 1 to 5? And that constrains the decisions to a numerical score from 1 to 5, which inherently reduces variance.
Except when it gets the score wrong.
Except when it gets the score wrong, exactly. So what do we mean by evaluation-driven development? Well, so when you're actually sending something to an LLM, you typically are assembling that context, you're adding it to your prompt, you're sending it to your model. Then after the model's given a result, you're actually processing that response. You may, if the model gives you multiple responses, you're picking what you think is the best response. You may add some additional guardrails. And so the question is, when you send something all the way through this flow, is the output any good? Is it accurate? Is it reliable? And so you need to have an end-to-end evaluation system. And when you do that, it needs to look at all 5 of these steps. It's not just at any one of these steps. It's how everything comes together. And to do this, in my experience, you need to actually have a wide range of inputs. And those inputs need to be adversarial. So imagine, put some profanity into your input, see what happens, right? So that's sort of a set of adversarial inputs. You need synthetic inputs, and this is where the big models like OpenAI's models or Anthropic's models are great. If you actually have a dozen prompts that humans have handcrafted that sort of show what's typical, you can actually then send it to OpenAI and ask it to create 10,000 prompts that are similar but different, right? And that's another good way to create those inputs. And then you should always have observability and log every single prompt in the real world. And so those inputs become the basis of your evaluation system. And then you need to send those in as part of a continuous testing and evaluation approach to measure the output. And of course, then the question becomes, how do you measure the output if it's any good? And I think it really depends on the application. But again, the most common approach is to have some defined golden expected outputs, and then you use an LLM to compare the real world output from your system with what you would consider to be your golden output. And that actually seems to work reasonably well. So last thing I'll talk about is just choosing a proven agentic AI platform. So LLMs unlock reasoning, but there's no free lunch. right? So we've talked about LLMs are stateless. It has no recall of prior interactions. So you need a memory system. LLMs need context. It must be told everything up front, right? Or as part of that enrichment loop. So you need a platform that has good tools integration, knowledge integration with vector databases and other systems where you're actually retrieving your knowledge. LLMs are stochastic. So the same input can produce different outputs. So you want to rely on deterministic workflows as much as possible, and you want to design for uncertainty. LLMs are unreliable, so they may fail to respond, they time out under load. Their sort of failure characteristics are not particularly good. So you really want to adopt a distributed mindset, systems mindset. An LLM can fail at any moment in time, and you want to use a durable execution framework. And then finally, LLMs are slow. So they're high latency, limited concurrency, so you want to use streaming to improve responsiveness.
Yeah, thank you, Richard. And obviously, I'm CEO of Akka, and Akka is a technology company. We've been around for 15 years. We were mostly known as a developer framework and set of libraries that would let you implement a very wide range of distributed systems. And when you built distributed systems with those libraries, those systems would ultimately be infinitely elastic, have a form of no downtime, upgrades, and guaranteed resilience. Over the last many years, we have evolved and we now ship a platform. We actually ship a development platform, and you can design, build, and operate data API and agentic AI services. We have provided an SDK. The SDK allows you, it's basically an agentic development framework. It makes it possible to build agents. Those agents can execute in a multi-step enrichment loop. There is a memory database for your context that is embedded inside your agents, meaning it's in process, it's in memory, and it's durable. And as a result of that, you can then do multi-agent orchestration with this over a distributed network, because you can execute workflows that have durable execution associated with that. And we also provide a whole series of connectivity and adapters to enable real-time streaming with LLMs and turning them into non-blocking systems that are event-driven with back pressure built in. And you can even see that with one of our examples, we show you how to do real-time video augmentation against a multimodal Gemini LLM, so that you've got the real-time data coming in, real-time data coming out of the LLM, and interacting with the user in a completely event-driven, non-blocking architecture. We have, over the years, we're just going to hop to the next slide real quick. Sorry, thank you, Richard. And we have, over the last couple of years, added in a whole series of AI capabilities. We're not going to go through and talk with all of these things right now. This is all available on our website, but ultimately, at the end of the day, we can help you design an AI system that has a high level of certainty, operates with an ultra low latency, can get to 6 nines of availability, because we enable multi-region operations with full memory replication between those regions. And with the nature of the way that we do things, we can guarantee resilience, that the system can always recover from any type of failure event. And with that, we've done some really interesting AI work with a number of accounts. And yeah, there we go. Sorry, just waiting for the slides to catch. There we go. We've done a bunch of work with a number of accounts, and these are machine learning driven and AI driven accounts, particularly Swiggy. It's out of India. They are effectively like the DoorDash for the Indian market. They do a multi-model, not multimodal, multi-model environment, which is doing recommendations and inference, and Akka Akka was used as the orchestration, batching, and inference layer, and they run at 3 million transactions per second at a 71 millisecond P99 latency for that orchestrated workflow. And another very interesting one is Tubi. And Tubi, this gets interesting because they have simultaneously incorporating a wide variety of data sources. Think of them as event streams coming from different locations about a user. And then they try to distill all of that information into content recommendations and certain types of personalization attributes as well. So that's kind of both a multi-model and a real-time streaming scenario. We hope that everybody, we're going to go ahead and finish.
Eric, did you want to say something, or should I?
No, we have about 9 minutes left, and we have quite a few questions because we covered a lot of really good materials. So to preempt people's questions, we'll cover this.
All right, yeah. We want to just kind of recap all the resources that we put at the beginning. They are available to you, but more importantly, if you have an interesting project, please get in touch with us, because without any obligation to you, we would like to take whatever your concept is and actually develop it and prove it out to you in 48 hours. So you can scan this QR code, send us the use case that is working on in your environment, and we'll follow up. And we've done this a number of times, and we'd love to show you how this stuff can work and how to make it reliable. So we'll leave
Sounds
that.
Great.
Hopefully, we can just leave that sitting there for people to scan while we do the Q&A. Eric, yeah.
Yeah, we'll keep that up. So I've seen Akka, you guys, over that last 15 years do quite a bit of this. So I really appreciate all the work. And normally we wouldn't kind of go direct into vendor things of what you do. But specifically, because of your history as a development framework, we did have a question here that says, is Akka providing a framework specifically for creating agentic multi-agent systems, or will it be Akka 3 as it is today augmented?
It's both, and right now, all of the examples that you'll see are based on the Akka SDK, which are endpoints, workflows, which can handle multi-agent orchestrations. But within that, there is MCP support already natively. Like, you can build endpoints that are NCP servers, and you can do multi-agent protocols like A2A. Where this evolves to, so there's really simple ways to use the existing capabilities to do that, but we are evolving it into a, let's call it agentic abstractions, because there is a little bit of overhead that goes into the way that the current SDK designs those systems, and we can make that overhead disappear. And so we will make that overhead disappear. And there's multiple ways that we're doing that. One way is obviously at a programmatic abstraction level. There's a bunch of things that we'll do, but a more intriguing way, which is trying to kind of leapfrog what's going to happen into the future, is we are doing, in an open source way, developing a prompt language, if you will, a prompt language specific to creating agents, and the developer experience for that is integrated through IDEs like Kudu, Windsurf, or Cursor, where you create prompts using the language that we've talked about here, and you're talking about the agents and the outcomes and the behaviors that you're looking for, and then it generates these distributed systems that are compilable and ready to go on that. And that's kind of the second thing we're working on, and we're doing that in an iterative fashion in the open source community.
All right, another question came in that's related to what you talked about, which says, what is the difference between A2A and MCP?
Richard.
So Model Context Protocol is a common protocol for agents to actually get access to what are commonly known as tools. So being able to extend your agent to operate a Salesforce API or retrieve content from a Postgres database. So that's really what MCP is. It's about getting more context or capability, adding more skills to your agent. A to A is a protocol proposed by Google, which is about how agents actually interoperate with each other. So MCP is really scoped to how an agent sort of interacts with other systems, and A to A is a protocol around how agents discover and cooperate and hand off data. So the two of them are very complementary and not competitive.
All right. Another one that came in here talks about for agentic workflows where tools, calling chains, or next step is not pre-known, are there any authentication and authorization frameworks to think about for these agents that fall in line with accepted security measures or enterprise identity?
So the answer would be not yet. What I've seen most people do today is that if you're creating a workflow and your large language model is creating a workflow, a lot of times you can emit that workflow as code that is then executed. And that code can also include authentication code that talks to your existing authentication or authorization flows. So I would say it really depends on the situation, but the general goal is to actually have a workflow that sort of incorporates your existing authorization authentication workflow, which you can do with the right context and prompts to your planning LLM, if you will.
And further, I would say that this enterprise authentication mechanisms is probably the biggest and most well-known cited deficiency on the existing MCP protocol, which, given the pace at how these things are advancing and the large volume of organizations that are working with it, I give it'll definitely be before the end of this year before that is a solved problem natively within the protocol itself.
It's shocking to me, right? Because MCP is 6 months old, right? And it's the standard now.
Yeah.
So
that's a pretty quick turnaround. To follow up on a previous question about the availability of the framework, there's a question here that says, is there a sandbox to playground to play with Akka Agentic SDK, presumably in private cloud or public cloud?
So the one of the things about the SDK is that you can use it entirely offline. You don't need to be bound to like our cloud or any of our infrastructure if you don't want to. So your only dependency there is Maven and Java. So we make it possible for you to build systems in a couple of minutes that way. The second is you can create a free account at Akka.io, and we run Akka.io as an Akka platform variant, which is you can take any application that's built with the SDK, and at Akka.io, it will scale up as far as you want to scale it to. And what we do is we give all the sort of agentic samples. They're already packed as Docker solutions, so you can create an account at Akka.io, deploy that sample, scale it up, and then you can go to the repo and see the code as well. What we haven't done yet is we haven't like enabled a Gitpod or a coder.com or a Replit sort of environment. So it's one of those two combinations.
All right, last question I think we can get to today, but I know there's different ways of following up with you for questions. How can the agents be integrated into complex legacy enterprise architecture? And do you have best practices to suggest?
So when you really got to do a domain-driven design to do an assessment of where where agents are going to best interoperate with your environment. There is a number of best practices here. So one, your agents are oftentimes working off of data. So you find interesting data that you need to summarize, synthesize, analyze, review, whatever that may be, right? That's a good starting point, cordoning that off, and then you basically are building up a new system that operates off that data. That's one access point. The next access point is off of events. So if you are generating traces, logs, or events off of some sort of existing orchestrated workflow, those events can be fed in to a new agentic system, and you use that event stream in what's called an ambient AI model to make recommendations or improvements. Again, that operates independently of your system. And then I think that the third thing, and this is really for the ambitious groups, those organizations that have deployed very complex rules systems and trying to work to displace those rule systems with a reasoning-based system on LLMs.
Awesome. So there's a lot of really interesting information here. I appreciate you having those additional resources there. After this webinar, because we're at about time now, we will send out copies of the recording. We'll send out copies of the slides so everyone can go through it. And feel free to get in touch and reach out with any other questions that you have. Thank you very much, Tyler and Richard, for the time.
Thank
you
you
everyone for attending.